So guys, with this video, we are going to talk about higher order partial derivative. As from the first video, we did the first order. So with a higher order derivative, it's also the same application, but the number of times the individual, you see, the order as in of a partial derivative is the number of individual derivative performed. So if you say higher order is more than 2, right? So first, these are some notation you should know for the higher order. We know this already. When we talk about small f of x, it means that the partial derivative of the function with respect to x. This is the partial derivative of the function with respect to y. Let's go here. This is the complex part, right? So with a higher order, we can get f x. That means that you're going to differentiate the thing 2 times, right? But we are going to differentiate with respect to x with respect to x, right? And how do we write this? See this. So that means that the function is your partial differentiated function with respect to x, and that function you differentiated partially. You're going to do another differentiated partially again with respect to x. We are going to do an example for you to see. Are you getting it? So this is how we can write it. Now, how do you write it? This the number of times it has been differentiated is twice, so it will be the partial derivative of the function squared all over the partial derivative of the x squared, because you are doing it 2 times, so x. This is the complex part. Now look at this. This and this, they are whole different things. You understand how you represent them. See this, we are doing partial derivative of x. So we are partially differentiating with x. Then they see the function that we've done to get the partial derivative of x. Then you do it again with y. How do you write this? You see this one, the x is starting, but here the s is what? The y is starting. So do you know the trick here? When they give you this, for you to perform it, first you change it to this for you to understand. That means you're going to do, you're starting from here. So you do partial derivative of the function with respect to x first, then you do with respect to y first. Note that you always start from here. When they give you this, you always start from here. You do it with this first, then you come here. Are you getting it? Please note that for this function too, you see, we are starting with what? You do partial derivative of y first, but here they started with the partial derivative of x. So when you are changing this notation to this, it's advisable that when they give you this, you try changing it to this so that you can do it very well. Because with this, it follows the order that you are doing with y and x. But here, you're starting with what? X and y. So you always start from the back that you first start with this, then you do this, right? So you change it to what? F of x, right? Then that will be y. You have y, then we have what? X. As simple as that. With this, you are doing it y 2 times. That's why it is squared. I hope you had that, right? Yes. So let's take some example that we should do here. Why they asking us to find, this is first order and we've done that already. So with first order, I know that you don't have a problem with that. And I know you've watched the video and you understood this. So the first order is very simple. The second order. So you've done, always when they give it to you and they ask you to find the second order, you need to find the first order and put it down, because they ask us to find all the second order. So that means that you're going to find f of x, x, y, x. So with this, you first find the f of x and f of y. Here, f of x. This is f of x. So you partially differentiate it again with respect to x. That's what they have. Because if you do this, you're going to send these 2 in front and you differentiate sine 2x. You're going to get cos 2x. That's why you had negative 4 cos 2x. And here, there's 2x here. So you just differentiate this because the e exponent 5y becomes a constant. So you're going to get 2e exponent 5y. So that means that you're going to differentiate the thing. You've differentiated the thing with f of x. Then you are also going to do another one, which is the second order of what? F of x. So you are doing it x. Here, you're going to take the f of x, right? Then you do it with y. So this is f of x. When you are doing it with y, this is the one related to y. So with this, you know that you are going to differentiate this and bring it in front. So when you differentiate it and bring it in front and take the whole function again, you're going to get what? Negative 10x e exponent 5y. Because you are taking the x value, this is f of x, and you are partially differentiating it again with respect to what? Y. That is how the second order. With the higher order, you understand. So the same thing applies to this. When you take this, you are going to take the y. So you've done the first order already. So you take the first order and do it again with respect to what? X. So with respect to x, you're going to get negative 10x e exponent 5y. You get it, because this one is standing alone, so this one becomes 0. Yeah. We have something called the Clairaut theorem. With the Clairaut theorem, right, it's very simple. That when you partially differentiate the function of f of x, y, you see, when you take this, the f of xy should be equal to the f of what, yx. If this theorem is achieved, then we call it the Clairaut rule or the Clairaut theorem, right? So for example, let's take this example here. The asking us to perform, verify whether it's a Clairaut or theorem. So that means that when you take this, you first find the first order. You do the first order. Then when you take the first order, this is the first order that we did. So always when they give it to you, the first thing you must do is that you must do the first order. Then you come back to the second order. F of xy. So f of x is this, y. We had this. So f of xy, we had this, right? So this is what we had. And then you go and take f of what? Yx. And f of yx, we get this. That means that I think here they made a mistake because uh f of xy and f of this must be xy. If they are the same, if you get the same value, that means that it's satisfied it is good enough that they are the same. Then therefore it satisfies the what? The Clairaut rule, right? That's how the Clairaut rule states. So the Clairaut rule that when you partially differentiate f of xy should be equal to partial differential of that small fy, like small fy fyx be equal to small fxy. And always note when they give you the higher order, get the first order and put it down, then you continue with that. Now we have third order. With the third order, you see with this, look at how they've written this. That's why I told you always when they give you this form, you should change it to this. First, you start from here. So you are going to get f of what? X, y, x. Here will be f of what? Y, x, x. Look at this. So always you must know how to convert this to this. And just start from the back. We have y here, so it will be f of y. We have 2x here, so it will be xx. Simple as that, right? So the Clairaut root also extends to the third order because with the third order to f of x xy should be equal to f of xy should be equal to f of y xs should be the same. So look at this. Find the indicated derivative. You are finding f of x x y z z. So you are going to do it first. Find the first order. Let me see. So first you need to find the first order first. So they find the first order of this with respect to x. With respect to s, what are you going to get? This is what you're going to get: z cubed y squared over x. So f of x x, you're going to do it again with x, and here you do it again with x. You use what? The quotient rule. You get this. You're also going to do it again with y. So you are just following what you are doing. You just do it, but note that it's partial derivative. When you do it with y, what are you going to get? Is it y? Here, when you are doing it with y, you're going to get 2z cube over 2z cube y over what? Negative 2z cube over negative 2z cube y over z squared. Because you are just dealing with what? The y. And in this case, it's attached to the z, and the z becomes a constant. So this is how we do it. And as simple as that. So you must take you must first find the first order, then follow up the procedures, and it's very simple as that, right? And these are some examples that you need to do. So let's go to the differential. So how do you change when they ask you to change it in a differential form? Simple. When you find the function of x and y, so this is the differential formula. So always the f of y, the f of x should go with what? The x, and f of y should go with what? The y. In terms of z, it also goes with what? Z. Look at this. So changing w's go to what? The g of x dx, g of y. So when you do partial derivative of the function of with respect to x, then you bring the x. Partial derivative of the function with respect to y, you bring the y. Partial derivative of the function with respect to z, then you bring the z. As simple as that. So with this, from what they did here was that they asked us to what? Compute a differential for each of the following. So with this, I'm just finding the z, and the z here is what we're going to partially differentiate it with respect to f, the partial derivative of this with respect to x, partial derivative of this with respect to y, and just add the x and the y. Look at this. So f of x here. So you find the partial derivative of this. That's the first order. This is what they had. Then you introduce your what? The x. Then you find it with respect to y. This is it, and you introduce your what? Your dy. As simple as that. So this is how we do it. It's very simple as that. Yeah. Thank you very much for this. Also, we are asking to compute the differential. Let's look at it. How many variables do you have here? We have 1, 2, 3. So simple. We are going to get You do it with respect to t, then the t. This is what you've done. You did it with respect to r, then the r, and you did it with respect to s and the s. This the minus is because of how the quotient rule. When you use it, you're going to get minus inside. That's how it is done like that. So very simple as that, right? It's very simple as that. Very simple for the differentials. So when I ask you to sometimes the differentials are also called total differentials. So when I ask you to find the total differentials, it's just you are taking the variables one by one. You partially differentiate the variables one by one. Then you just add with respect to their variables. So you partially differentiate the t. You have t, and then you do the t, r, the r, s, the x. Thank you very much for watching this video. Thank you very much for watching this video. So the next video I'm going to talk about is mid-sem review questions. So I have a computer-based mid-sem questions that I'm going to review to you guys, and I hope you like it. But before that video, we'll be taking some examples that we solved. Some examples that I'll explain. That 2 examples for you to understand whatever we've done. Thank you very much for watching this video.